All right, class. This is 20B problems. Number 32, a voltaic cell that has a reaction. That's PD as in palladium, PD, D as in dog, Cl4 with a -2 plus cadmium, CD solid, yields PD, again, palladium, PD, plus 4 Cl minuses, and there we go. And CD cadmium with a +2. So has a measurement of standard E cell potential. That means the E cell part like this equals, so instead of like the cathode minus the anode, we know what it actually is. It's 1.03 volts. That's a positive, plus 1.73 volts. Okay. So this asks us to do the two half reactions. So the two half reactions, one of them is going to be palladium chloride, and that has a -2, and that's going to go to the other side of palladium solid, which means it's 0, plus, and then 4 Cl minuses. Now the Cl's in this case, because if we take a look and try and find out what the actual charge is of palladium, we know that Cl has a -1. If there's 4 of them, that's a -4 total. Okay, and that all equals a -2, which is why that's the charge of the polyatomic ion. So what is palladium then? Palladium must be a +2. So that gives me a +2 here. +2 goes to 0, which means this must be reduction. This is reduction. This happens at the cathode. Okay, we don't know what the E reduction of this is because it's not on table E or appendix E. So let's take a look at the other part then. Move down just a little bit. Good. So what's the other part? On this side here, we have CD as a solid going to CD with a +2. There we go. CD is a solid, like that, going to a +2. That means CD is in its natural state or 0. CD with a +2, like this. Oh, I didn't do the electrons. So let me go back up to the other one. If it's a reduction, electrons are on the left-hand side. That makes sense, actually, because I got 2 minus charges plus a +2 charge for palladium gives us 0, which is what we have on the other side. So 2 minuses plus a +2 gives us 0, and that's what we have on the other side right here. So that means on this side, then I'm going to do exactly the same thing. I'm going to add 2 negative charges or 2 electrons right there. These two combine to give a total of 0. Okay, and then my E. This, by the way, if the electrons are on the right-hand side, that means oxidation, that means anode, and that means that my E reduction for this, even though it's written as a reduction, is 0.403 like that. So that's where I am as far as, now we don't need to show that stuff just yet, but this says by using the data from Appendix E, determine E reduction for the reaction involving the PD. Okay, so here's how we do that. I'm going to scroll down, give myself a little bit more room. There we go. Give myself even more room, like this, because here's what I know. I know that E cell equals E reduction at the cathode minus E reduction at the anode. And because of that, what I know is that I have positive 1.03. That was given to us up above. We don't know what this one is, and that's minus a -4.403, I believe. And we look on Appendix E for that. I don't think I have Appendix E in this PowerPoint, so you have to flip to the back. I included it, I believe, in this assignment. Okay, so let's go through with this then. All I have to do, because this is a plus and a plus, to get this on the other side, is to subtract both sides from 0.043 like this. So minus yeah, no, that's written correctly, but that point should not be there. 3 like this. and that gives me a positive 0.627 or something like that. Yes, I'm almost positive that's what it is. Okay, so this right here is the E reduction of, there, and that's volts. Excellent. So that is just that one. I'm going to stop here so that you, so that this doesn't get too long.